So do you have an idea for how long you need to wait? 3 months. Hello, test. Okay, so we are all set. So thank you everybody. Boa tarde todo mundo. Obrigado aí pela presença. So today we have an invited talk. So it's Dr. Qing Yuan. She holds a PhD from Beijing University in China. Has been a postdoc at INTRIG in France for over a year now. And we have been working together in the scope of a joint project funded by FAPESP and INTRIG on intelligent transport systems. The project is called DRIVE. And within the project, we realized how machine learning could be beneficial for multiple channeling applications from multiple angles, and we ended producing a survey paper, which is that one, that is under submission, which covers a broad overview on how machine learning and artificial intelligence is being used in this big topic, which is ITS. So I asked Tintin to use the opportunity. She's visiting us for 3 weeks, right?
Yeah.
last week, so it's still a chance to talk with her maybe later today or tomorrow. To provide an overview of the survey. Of course, it's an overview. The survey is pretty dense, but I hope you enjoy it. And thank you, Tintin. And most welcome.
Hello everyone, this is the first time for me in Brazil. I think I'm very like this city. And today I'm going to talk about the machine learning in ITS. It's our survey works. It's actually my first work in my postdoc. Here's the agenda. I'm going to introduce the introduction and the background of our talk about ITS and machine learning. And then we give a framework on, with machine learning for ITS. Then I will talk detail about the previous works on machine learning driven ITS text, include the perception, prediction, and management. And last, I will talk about the future trees of the machine learning used in ITS. First, what is ITS? ITS is an intelligent transport system. It includes telemagnetic and all the types of communications, including between the vehicles, like way-to-way, vehicle-to-vehicle communication, and the vehicle. The communication between vehicle and fixed locations like infrastructures, it's a way-to-eye communication. And here we give ITS framework. The lower part is the ITS environment, include the vehicles, trees, and the road stations, and also people here. And based on that, we give the ITS framework. It includes 3 layers about the infrastructure layer, including the sensor part and the communication institutions, like the roadside units of the communication part of the router or switch, and also vehicle maybe work as the communication part. And about the resource layer, it includes the computing resource, storage resource, and networking and energy. And the orchestra layer, it offers a more higher level. It offers the global view of the ITS framework. It can also other APIs for resource management and the infrastructure management. And for the application realm, it in particular because it can deploy in different layers. For example, the autonomous driving can be deployed in the vehicle, and for some resource allocation, it can be deployed in the resource layer. Here we give the base part of the ITS applications given by ETSI. Here is 4 class. This is the basic set of the ITS application. And by now, there's more and more applications because the development of AI. And here they give 4 classes. One is the road safety, another one is the traffic efficiency, and the local service cooperative, and the internet service. We found that if we want to use the application definition to help us to understand what machine learning do, it's a difficult problem. So why we need AI in the ITS? This is called the ITS requirements. Because we want to more autonomous of the driving, autonomous of management, and we also have a lot of new applications visual-based management. And we also need something like the human-like performance, like more reasonable and more reliable. Here we use the text decomposition of the application. We know that ITS application may be more complicated to understand what machine learning can be done. So here we definite the task about the perception, prediction, and management. Perception is based on the resource, some data from the sensor, all the cameras and processing the data to do some traffic sign recommendation, passage trains detection, and vehicle detection and road funding. Based on that, we can do prediction. For example, the traffic prediction and the behavior of other vehicles action. And for the management, we can based on the perception and also use some results from the prediction to offer more detailed management of the future. Here, I give some example for the path and trajectory and the battery of electronic cars and motions, like how to turn right to turn left. And then based on the ITS framework, we blend machine learning into this work. Here, this part is ITS framework, and it collects some data for the machine learning. We all know that machine learning is data-driven work. So the collected data will come to the machine learning pipeline. And the machine learning part will do some classification, recognition, or making decision. And this part will be applied into the text we have mentioned. And this text will support the application will to do some important tasks. And then I will introduce the machine learning pipeline step by step. The first part is data pre-processing. It includes the data cleaning and the data normalization. And this the data in ITS can be included two parts. One is traditional sensor, from traditional sensor, like magnetic sensor, include inductive loop detector, GPS or read. And another part is it's very important for machine learning is vision-based data. For example, the image and the video, and also this part of the data can be in space and the time data. And based on the data processing, we can do some feature extractor. Here I will introduce two kinds of the feature extractor. First one is handcraft feature. For this one, we can use the color-based features like RGB or LAB. However, if we think about the image data come into the machine learning, there's a lot of pixels. So when the data is growing, it will cost something like the computation expensive. So the expert get another thing of the handcraft feature. It's hard like HOD. It uses something like the window to pass by piece and gather some implicit vectors. And the HOD use the gradient vector to gather pictures. This one is machine learning. It's based on deep features like BNN, for example, CNN for the figures, RNN for the sequence data, and the JN is graph neural network. It's for the for some data have strong structures. Here I give an example of the figures. Use JN to get the features of one figure. Here's convolution layer and the polling of getting the data, and use the phone connected network to get the classified. And compared with different kind of methods, this paper shows handcraft approach has lower accuracy and it costs less computation resource. And for the CN, they will cost more computation resource but offer more accuracy. So some working on the schedule CN to get a balance between the computation and accuracy. The next step is modeling. Here we have three main kinds of machine learning methods. One is supervised learning. And another one is unsupervised learning. The third one is reinforcement learning. And combined with the deep learning, we have deep supervised learning, deep unsupervised learning, and deep reinforcement learning. Given problem, what kind of method we can use? Here is show the things they can do. Supervised learning is based on labeled training data. It's used to predict the things in the data. And it will get the direct feedback to training the data, training the model. And unsupervised learning is based on no-labeled data. They can explore the things inside of the data, but they will get no feedback to training. And reinforcement learning, it can be zero shot, but it needs to interact with the environment. And by taking the action to get the reward, it will learning how to update the neural network of the agent. The last thing, if we get a model, we can use for the classification and the regression. This is for the supervised learning. And for the unsupervised learning, it can do clustering and the dimension reduction. And last, for the reinforcement learning, it can use it to making decision for management of control. With all the things they can do, we can apply for the ITS text and then benefit for the applications of ITS. Then I will introduce machine learning for different texts. The first one is for machine learning for perception. Here we consider different categories. We include the road, vehicle, and the users. First one for the road. There are more include the signs on the road and the condition of the road and the recognition where is the road. And this one is more complicated. It needs to understand what is the surroundings. This case category 9 different categories of the image, including the train, the building, and the sky, and the vehicle, and so on. Here we can see that most of them use the supervised learning because they can have some data of what kind of this marks is to tell as a label. And some of them also content with CN to get the feature from the image. This is one for the vehicle perception. It includes the detection of the vehicle. For example, this one, detect the vehicle on the road, and classification and identification or re-identification. Re-identification is more difficult. It needs to tell the detail of the vehicle. And another part is for the part of vehicle. For example, the lights of the plate of the vehicle. This part also can be used for the re-identification of the vehicle. And then I will give an example of the machine learning for vehicle classification. This case uses the CN here to get the features of this vehicle. And after that, if you get the feature, you can use the supervised learning, or you can use the fully connected network to classify this car or truck or something else. This example gives the probability of one classifier. The last part is perception of the user. It includes the driver perception and the pattern trace detection. The second part for machine learning is prediction. It can predict the traffic of the road and the travel time about the train or the bus to help the passersby to schedule their time, and the behavior of the cars to help the following cars to drive, and the road occupation. You know, it's important for urban cities to find a place to parking your cars. So this one will predict the parking slot and for the user to use. This case is for the prediction of the cars move paths. It can mostly based on the past station of the road and past station of the cars, and predict the future of the moving of the cars. For the prediction, most of them also use the. So this is a time sequence problem. So most of them will use the RLSTM. It's a neural network for the time sequence problem. The final part is about machine learning for management. Here we include two parts. One is about the infrastructure of the traffic signals and the vehicle. Another part is about resource, about network, computation, and energy. Here in this topic, most of works use the reinforcement learning because it has good performance in making action. Here is an example. For the ITS network, ITS environment, they give the state of the agent, and the agent will make action to influence the ITS environment. And the ITS environment will take this action and make some change. And then they give the reward to the agent for update. This, we all know that Q-learning or deep Q network, it is famous because of the AlphaGo given by DeepMind. We set the past topic on this infrastructure management. It includes the traffic light, like this one, to management according to the the queue lines or the speed of the traffic. And this is electronic speed board. And the vehicle management according including the trajectory, how to get the path from your target position, and motivation is how to do action point at each of the points. And the last part is about the resource. The ITS network, for the ITS, the resource also one critical part in the ITS. So how to schedule the resource to offer better performance is very important. Here some works on the network resource management and the computing storage and energy management. Also, most of them use the reinforcement learning method. And the last is about the future trees. I think the future trees is more higher dimension of perception, from the 2D understanding to 3D and 4D and 5D. 4D is based on 3D, they add some temporal time, it's about time prediction. And 5D is based on 4D, they need to understand the interaction between vehicles or between the human beings. So it makes it more reasonable to rely on this kind of perception. Another future tree is about cooperate ITS. Actually, it's not a new topic. It works a long time. But how to make them cooperate with each other, also a hot topic. And based on AI, we can imagine how to share our data, privacy, and cooperate to make one world more better. It's about multi-agent problem, I think. And another treat is about the new vehicle. For example, the UAV. Here, UAV can work a lot of roles. For example, the flying RSU, roadside unit, for communication, and also for delivery, or for the controller of the vehicles. The last cheat, I think, is AI will be served as a service. We don't need to model task one by one. We need a shared model And this shield model will be transformed to the network. It's about transform learning. And this model will be works for this task. And based on the working